All right, welcome everyone. Thank you so much for joining today's event. My name is Bo. I'm with Acelab. We are helping out hosting today's event with Mitrex and Cloudify. It's going to be an AIA-approved course on taking advantage of your vertical services with building integrated photovoltaics. So super excited for today's course. I know a lot of architects and designers have been wondering how to start integrating these products into their projects. So really excited to get some of this information out to you guys today. I'm going to give folks a few minutes to join and just give a quick little intro about Acelab, show you how to find Mitrex and Cloudify on Acelab's platform, and then we'll go ahead and get started with today's AIA-approved course. All right. So as I mentioned, Acelab, we provide free non-sponsored product research. So our platform is free for architects, designers, and specifiers to use. We are built by architects for architects. So here's a little snapshot of our team. I'm a former architectural designer myself. So we really all are, doing this work and have come at Acelab with the goal to create the tools that we wanted ourselves in practice. So here's a little example of some of the kind of workflow issues that we are working to solve. So just being able to track down product information, find products that you've used in the past, as well as get in touch with reps at those critical moments. We have been building a platform where you can do all of this work in one clear, organized space. I'm going to give you a quick tour to show you how to find Mitrex and Cloudify on Acelab. If you have any questions about how to use Acelab for your product research or to organize your product libraries, please feel free to reach out to me after today's event. So here I've logged in. I've got my custom dashboard view where I can see all of the work I've been doing. We've got a bunch of great searchable categories where you can go and have a guided search experience. Those are all accessible at this dark blue bar in the top. But if you know exactly who you're looking for, you can always just use this search bar at the top, type in the name of any manufacturer, and that'll auto-populate. You can head over to their brand page on Acelab, get in touch with them directly through here, explore their products directly through here. And I'll show you real quick some of the benefits of doing that are not only that Acelab's brand pages are all organized the same across different product types and across different manufacturers, so you always know where to find the information you're looking for, but you can save these products really easily either to a general location or to a specific project. So I'm going to go ahead and do that with a few of Mitrex and Cloudify's products so that you can see what that looks like. All right, so you can see I've shortlisted all of these to my general research project. I'm going to show you real quick how to find that. Pop over to my project portal. All of your stuff is over here in this library tab. So that's where you can find all of the stuff that you've been doing. Jump into my general research project. And these are all of my products that I've saved, organized by product category. Anytime I open up one of these lists, I get a really handy comparison table where I can request more information. I can add comments so that I can be able to, save information and internal comments from my team or my clients. And you can scroll down and see an overview of design options and product information. So it's a really great way to save and store and organize your product info. It's just one click to have all of this information automatically saved into a comparison table. And we even host downloads right here. So you can download specs, you can download CAD details and files. We also host that right here. So it's pretty easy just to keep everything all in one place. All right. And that is it for my quick little intro. I want to thank everyone again for joining today. And without further ado, I will go ahead and hand it over to Terri Oswald. Terri is going to be providing today's AIA-approved course. We also have Tonya on the call from the Mitrex and Cloudify team. We will definitely have some time at the end for questions, so please feel free to submit those throughout today's presentation. And if we do not get to your question, we're going to have a report of all of those, so we'll follow up with you after the event if your question goes unanswered. All right. And one more quick housekeeping item from me. In case we do not have your AIA number, I'm going to send over a quick form in the chat. So please, when you get a chance, just submit your AIA number to this quick form. That'll make sure we have a record of it. And you can also request a certificate through that form if you would like. I will send this again at the end of today's event, just in case anybody joined a bit late, they'll be able to still access it. All right. That's it for me and my quick intro, and I will go ahead and hand it over to Terri to get started with today's AI-approved course.
Wonderful. All righty, so let me just share my screen and bring up the presentation. Start from the beginning. All righty, so thank you everyone for joining. This is very exciting for me. I travel a lot to the US and throughout Canada, and I am always enthusiastic about the response that we get regarding our technology. So any opportunity that I have to express the pride that I have in being involved with Mitrex and being able to share the technology with people, around the country is very exciting for me. So the course today is called Take Advantage of Your Vertical Surfaces. And as Bo mentioned, it is an AIA accredited program. The program is registered with AIA CES for continuing professional education. So as such, it does not include content that may be deemed or construed to be an approval or endorsement by the AIA. So we're very clear about that. As long as you provide your AIA registration, we will provide provide your AIA number, and we will provide registration on your behalf, okay? So as I said, it is one full learning unit. And the course description, it's very simple. We are looking for ways to effectively combat climate change. And so we as an industry need to acknowledge the role that the building industry plays in global CO2 emissions. So we need to shift not only how we think about designing our buildings, but also powering our community. So today's course is going to discuss how BIPVs can be integrated into both new and old buildings to improve performance and aesthetics and lower energy costs. So by the end of the course, you'll be able to recall the basics of solar energy, describe BIPV, and discuss how they improve upon traditional photovoltaics, demonstrate ways to incorporate BIPV systems into existing or new construction, and illustrate the energy savings possible through BIPVs by analyzing market research and case studies. Okay, so here we go. Sustainability in the building industry. So CO2 emissions from buildings reached an all-time high in 2019, and buildings were responsible for 40% of global energy-related CO2 emissions, primarily from space cooling appliances and electric plug loads. I came across a statistic that just about blew me out of my chair when it says that we are producing the equivalent of Paris in CO2 emissions every week and on track to do so continually. That is just a staggering, staggering stat, if you will. So the question is, how do we achieve sustainable buildings? So sustainable materials with low carbon embodiment, sustainable buildings by performing a life cycle analysis of construction materials, very important. Renewable energy generation, such as BIPV, are high performing systems. So there are ways to do this, and there are solutions out there, and that's what we're here to talk about. So the basics of solar energy, very simple. First discovered in the late 19th century. Photons carry energy proportional to the wavelength of light. So what happens is surfaces absorb light energy, and with enough energy, that surface releases electrons, creating electricity. So materials that use this are called photovoltaics, right? PV or solar cells. And there's two types of cells. There's monocrystalline silicon and there's thin film photovoltaic. So what exactly are they? BIPV is a sustainable energy generating facade. In most cases, you can integrate this at no extra cost. It's energy efficient solution for both existing and new facades. And the surface provides endless design options. So it's a customizable facing. It's a solar cell beneath that. And the facing is a light, or rather a tempered low iron glass facing that starts off clear. And then you apply coatings to it to create colors or patterns or both. And the backing of that panel is aluminum honeycomb technology. So it's ultra lightweight and extremely versatile. So BIPV technology is currently the cheapest source of energy in the world. So we can generate substantial percentages of the total electricity demand of a building. The solar facade will significantly reduce a building's carbon footprint, and a building with solar facade can take advantage of government incentives. Right now in the US, you are fortunate that incentives are 30%, and that is minimum, depending on the nature of the building, if it's affordable housing or other types of buildings, there's more incentives that you can factor into that. So it is significant. The technology is very simple. So as I said, the facing is fully customizable. You've got your solar cell behind it, you've got your back sheet behind that, and you have your aluminum honeycomb. But the real magic happens in the facing. So the glass remains the same, but the look of it changes. Whether it is a monochromatic color, whether it is a pattern that you are applying, whether you're looking to replicate an existing material, or whether you're looking to create something totally unique. I know it sounds kind of crazy, but you can take a photograph of your favorite plaid shirt and put that on a BIPV panel. And if you'd like, the entire west elevation up to the 15th floor can look like a plaid shirt, literally. So anything is possible. And that really is what sets this technology apart from a lot of other technologies out there. And the installation system options that are available to you are, you know, in simple form, rain screen, which you're all very familiar with. We have a prefab wall system and a precast wall system. So lots of different ways to integrate this technology into a building. And as far as other areas on a building that you can easily consider BIPV for is solar railings, whether it's an opaque design or semi-opaque, or transitional or semi. There's a lot of different design options, as well as a lot of installation system options, from a simple post and cap to a base shoe railing. So depending on the design, a lot of things can be integrated. Solar glass as well, 2 layers of heat tempered glass, laminated together in various patterns, generates energy while maintaining the functionality of the glass. So whether it's in an IGU or whether it is integrated into a spandrel panel, a lot of ways to integrate this technology into the design of a building. And as far as the BIPV components go, it is the same as your standard rooftop array or your solar farm array, all the same components. The only difference is we are looking at vertical integration. So your inverter and your switchgear and your rapid shutdown device are all part of it. The only thing that changes it is that it is vertical instead of angled. And connecting to the grid is fairly simple, but it does vary, you know, depending on the region that you live in. So in most cases, the electricity grid is your backup. There are feed-in tariff programs, there are net metering programs. So again, I'm not an expert in every area. So we rely on the good folks that reside in those regions to, you know, to fill us in on how that works. So here is an example of a rain screen application, okay? This is a courthouse government building in Ontario that was looking for a major retrofit. So an old building that was in need of a facelift. 2 active elevations, 160 kilowatt system size, producing some substantial electricity. And in this particular project, you know, all of the questions that come to the mind of the architect and the developer, you know, is how do you hide the cables? Where do the cables go? How do you install the panels? Are they vertical? Are they horizontal? You know, what does it look like? It's kind of hard to, you know, imagine where those wires will go. But the fact is that every building is different. What I can tell you is that the connections themselves are very simple. It is a female and male connection. So all of the wiring gets hidden behind the panel. And then all of the lines that connect the panels are, you know, fed through conduits. And conduit installation, again, looks different depending on the building. So if it's a retrofit, it's one way. If it's a new build, it's another way. You know, where the home run cable goes, where the inverters go, those are all questions that are asked during the you know, design process once we really get granular into a project, because it changes from project to project. Electrical connection, panel to inverter into the electrical room, which equipment we use. All of those questions get answered as we go through the process. Our technology is agnostic. So whether it's SMA or Fronius, it doesn't matter. As long as it is a reputable brand, we will attach to that. the benefits to BIPV are many. The obvious is generating electricity. What you want to do and what you can do is turn a building into its own self-sustaining micro power plant, right? And then the next obvious is the aesthetics, because up until now, aesthetics, solar technology is nice if you can hide it, but no one's going to put it on the side of their building because it's ugly. Let's be honest. So aesthetic is really important, and BIPV offers the flexibility, enabling solar panels to blend harmoniously within the building's architecture. So the technology is malleable, and you can control that as opposed to the technology controlling you. It reduces energy costs, there's environmental sustainability, obviously reducing the reliance on fossil fuels, lowers greenhouse gas emissions, and promotes clean energy generation. So all very important factors to when considering BIPV. So the applications are many. The philosophy is simple. Regardless of what the building is, whether it's a stadium, a hospital, parking lot, a data center, it does not matter. The fundamental belief is that any surface that is touched by the sun should and could generate its own electricity, regardless of what it looks like or where it's located. Now, geographic location will affect performance, and we'll get into that in a moment, but the fact is, here you see examples of BIPV being applied to projects. So industrial, data, high-rise, low-rise, institutional, doesn't matter. There's a lot of potential, right? As far as solar railing, again, very, diverse into how it can be integrated into a project. And as far as solar glass goes, again, design options are varied. You could have something that obviously looks like solar technology, or you can color the panel and it can be integrated into a spandrel panel or some other design where it's not so obvious. Those decisions are up to you as the keepers of the design faith. And as far as applications go, there are a lot of things that we look at when we look at a building to determine if it's a good fit, because not all building design is a good fit for BIPV. So the biggest area of opportunity is your cladding space, right? That is where your client will get the biggest bang for their buck. So cladding is number one. Balcony railings is the easiest swap out from a standard balcony railing to a solar balcony railing. So that's the second largest area of opportunity. And then there's other areas like spandrel panel, integration into curtain wall, window wall, that kind of thing. So lots of areas to consider. Retrofits are a huge opportunity. There is a vast amount of old buildings that are in need and will be in need of a facelift. And what better way to update a building than by wrapping it in solar technology and having it look much better than it did and continue to provide electricity. So project considerations. The next section, we're going to talk about designing with BIPV. So there's a lot of things that we look at and there's a lot of different products that you can select that will help you reach the performance objective that you and your clients are looking for. So early collaboration is best. We love meeting with architects and engineers, and you should, to ensure that you've got successful integration and design coherence. So color selection is important. Installation methods are important. Understanding panel layout and electrical design. Those are all elements that need to be considered, right? So the color that you select for a BIPV panel is really important. I do not expect anyone to look at this color wheel and remember the difference between a light red or a dark red or a light green, a dark yellow, and what that will produce. But if I can ask you to remember two very simple rules. Number one, the darker the facing color or pattern is, the more power it will produce. Number two, at minimum, any of the colors on this wheel or any RAL or Pantone color will produce at minimum 12 watts per square foot. Okay? Those are the only two rules you need to remember. And then what the panels will produce anywhere in between, that will be determined when we do a full analysis of the color and the project, et cetera, right? And we have ways of optimizing on colors as well. So as you can see there, that's one color before optimization. And then we've got a slightly darker color after optimization. And that is all in the process of how the color is applied to the panel and how it is produced. So lots of different things to consider. As well, geographic location is very important and building orientation is very important. You can take this building, hypothetically, located in Toronto, pick it up and drop it in Austin, Texas, and it will perform very differently. When we look to analyze a building, we look at all elevations because, believe it or not, the north side, even though it doesn't get direct sunlight, it will generate electricity based on indirect light. So the north side will produce almost 50% of what the south side will produce. So all elevations work in harmony to create electricity. So we look at all sides. And then we take a look at, the differences between vertical, horizontal. Obviously, when you've got a roof panel that is tilted and facing up, it gets sun at all hours of the day and night. On a vertical application, you're not getting as much, but you are still generating a significant amount of power. So all of these things come into play when we're analyzing geographic location, color of panels, where the panels are being applied, et cetera, et cetera. And then through a very detailed analysis, we can figure out very clearly how much power that building will generate. So sustainable material selection is important. Collaborating with architects and engineers is very important. Balance between aesthetics and performance, that is the sweet spot. So understanding what you and your client are looking for. You're looking for specific power generation, or is it more about aesthetics? And finding out what the orientation of the building is so we can really determine what the performance of that particular project will be. So those are the important elements to consider. Testing, certifications, this is super important because there are a lot of building materials out there that are available, but not all have the same certifications and potential that this does. And this is really important to remember, right? Because fire safety, of course, being the biggest one. Now, this is an example of what our testing results look like. Anybody who wants the specific testing, there are pages and pages that I can provide you. Too much to go over in this particular presentation, but all of that information is available. But what I want you to understand is that we go beyond the standard testing processes. We do all of our testing in-house first before we send it out to an organization like Intertek to provide third-party endorsement. We have all testing, both for building code compliance and for photovoltaic module performance. So S134, NFPA 285 for fire, E1886 for windstorm, E1996 for missile impact. We are certified in Miami-Dade, which is not an easy certification to get, if I may add, and the California Energy Commission. So everything for strength and durability, for fire safety, for surface safety, all those tests have been done. And we have no restriction as far as how high we can go on a building because of that testing. So if you've got a 90-story building, we can go to the 90th story, whereas other technology does not have fire safety. So you can't go past the 6th floor. So you can integrate it into the podium or maybe a few floors above, but that's it. So all of the testing really comes together and provides you with the material that has passed every safety and performance test that you can imagine. As far as LEED goes, you can get roughly 40 points with this technology. So it's really important because for a lot of buildings that are looking to achieve a particular LEED standard, this can certainly contribute to that. And the government are stepping in. As I said earlier, there are financial incentives in the US. Here in Canada, we salivate at what you have. We used to have conversations about the possibility of following what's in the US, but we have yet to get there. So we are still at 15% in Canada versus your 30+%. in the US, and companies are aligning with sustainable development goals as well, understanding that they need to operate within their communities. They are really making an effort to take into account environmental objectives. So it's really important, and it's impressive how far we are coming, right? Now, solar market projections is a really interesting slide because I was shocked, to be quite honest. So this basically represents gigawatt production. So in 2018, North America produced 55 gigawatts of power. We are on track to get to 437 by 2030 and 1,728 in 2050. That is absolutely staggering. Asia and Europe are pretty aggressive as well. So this gives you a good indication of where the market is going at. And years ago, what was a barrier was the cost of solar energy technology. But the fact is that now worldwide averages for modules have dropped 78% from $3.25 per square or per watt rather to 72 cents per watt. So that is a substantial drop. So it's making it a lot more affordable. So the reasons not to integrate are slowly disappearing, right? Embodied carbon, of course, that is a topic that we are always talking about. BIPV is a carbon negative product. So it's a building material that not only pays back its embodied carbon in under 5 years, but it also acts as an offset to embodied carbon within the rest of the building afterwards. So the environmental impact is pretty clear. You can either, put a ton of cladding on a building. You've got 100,000 square feet, and you can make a substantial difference, or you can spend a lot of time planting a lot of trees, right? And in conclusion, there are a lot of reasons to integrate BIPV into your project. It's a high performance building material. The testing is there. It's fire tested. The aesthetics are customizable. It's a lightweight panel. You're looking at, 3 to 4 pounds per square foot. You've got acoustic performance. As far as ESG goes, carbon negative. There's just the reasons for integrating BIPV are many. I can't list them all in one presentation. And if anyone wants to get into a really detailed discussion as to what the benefits would be, I'd be more than happy to speak to you one-on-one for that. And as far as the benefits go, depending on what your perspective is, today we're architects. So from your perspective, it's very clear what the benefits are, right? If you're an owner, you're looking at cost savings. If you're a GC, you're looking at installation ease. You're trying to eliminate logistical challenges. And all of those things are addressed when incorporating Mitrex into your project. So hopefully now you'll be able to recall the basics of solar. You can describe BIPV and discuss how they improve on traditional photovoltaics. You can demonstrate ways to incorporate BIPV, and you can illustrate the energy savings possible through BIPV. So that is the formal presentation. And I'm going to stop sharing my screen. And I'm going to turn my camera on so you can see the face behind the voice. Here I go. I apologize that the way I look like today is not what my profile picture looks like. Hot, humid day, and I've slicked my hair back because me and humidity, we don't get along.
Yes, understandable. Awesome. Thank you so much for that, Terri. That was a really great presentation. We've got a ton of questions. So if it sounds good, I'll just start kind of reading them off and we can start talking through them. Also, while we're here, I want to encourage folks who might be interested in asking a question out loud. Feel free to raise your hand and I will unmute you if you have a question that feels easier to ask out loud or a project specific question. It can be helpful sometimes to talk. You don't have to turn your video on, so don't worry about that, but just want to give folks the option if that's something they're interested in. All right. So I think we covered this one. Are the panels impact resistance and can they be installed in hurricane prone areas? Answer was yes. So that's really great to know. Cool. Right. And the next one, if the equipment runs on DC power, can the building use that without converting to AC and then going back to DC?
No.
No. Okay. And
One day
then,
that'll happen, but we're not there yet.
yeah. This person asks, are you seeing development with biomass? They work in biomass. I'm not sure what that means.
I'm not sure what that means.
Okay, well, Gladys, it looks like if you want to elaborate on that, you could feel free to raise your hand or submit another question into the chat, and we will try to clear that up. Grant asks, what is the lifespan of these panels compared to other typical building cladding materials? What is the failure rate or replacement rate?
Great question. So lifespan, I think it's safe to say it's going to outlive me. I'm not going to tell you how old I am, but it will outlive me. So we have a 25-year product and performance warranty on the panels. You're talking about a layer of tempered glass and a layer of honeycomb technology. The combination of the two are super strong. In most cases, they outperform most of the building materials currently available on the market. So from a material performance standpoint, it is impressive. We guarantee that at the 25-year mark, the panels will produce still 80% of what the original target was. So if we told you at the time of installation that the panels were going to produce 15 watts of power per square foot, then you'll get 80% of that at the 25-year mark. And they will still continue to perform for years after that.
Cool. All right, from Duncan, a vertical surface results in a higher incident angle. Normal equals 0 in their definition. If that angle gets too high, Brewster starts to work against you. What sort of % reduction in energy production can I expect for a horizontal versus vertical mounted panel?
So, okay. That was a bit more technical than
yeah, complex.
So vertical, okay, so let me just be clear here, and hopefully this will make sense. When you're looking at a rooftop solar, for example, angle, right? You're getting full performance there, which is 22%. In a vertical application, you're getting roughly 18%. And to simplify things even more so, you're going from getting 0 on your facade to getting 18% on 4 elevations. So you're going from 0 to hero very quickly.
Cool. This is from Youssef. What is the price range of these solar elements, cladding, railing, etc.?
Right. So our pricing points are extremely competitive with ACM pricing. Here's the difference. Oops. Sorry, this thing just came up.
Oh, sorry, that was me.
That's
Just
right.
since we had a price question, if you have some of those specific questions for folks in the audience, there's a quick little poll. You can let us know your interest there. So for more specific pricing and all of that, the poll is a good place to put those inquiries.
So pricing is extremely competitive with ACM pricing. I'm going to give you a very simple scenario to put all of the pricing in perspective. Your client is building a building with 100,000 square feet of active cladding. The cost of the facade is going to cost him hypothetically $5 million. Your client has a choice. Spend $5 million on a cladding that produces nothing. Well, I shouldn't say nothing. It'll close the building, and that's great, and it'll look great, but no electricity. Or for $5.2 million, your client can have the same great looking facade, and it's going to work for him or her for the next 30 plus years. So the cost for any other building material is what it is, and there's no tax credit. So if you incorporate BIPV, not only are you looking at a very competitive price to begin with, but then you're going to factor in 30% tax credit, which in many cases will bring the price below other building materials.
Well, I think I was talking to an architect recently who was telling me a story about how they had used a building integrated photovoltaic panel for a project. And it did end up, I think, like saving them money in the end because of the tax breaks and because of what they were eventually able to produce with the energy costs. So I think, yeah, it is really like when you're looking to those, long-term savings, it really does kind of even things out, even if you're maybe spending a bit more upfront.
It certainly does.
Yeah. Okay, from David Marin, how thick would a solar railing need to be?
It depends on the specifications and the height of the building. So we will work with whatever specifications you provide. So if it is a single 3mm glass with a galvanized backsheet, or whether it's glass on glass and you need 6mm in total or 8mm, depending on what the specifications are for the building, we will work within those parameters.
Okay. I see we actually have a hand raised. So Rosmal, I'm going to unmute you and see if you'd like to ask a question out loud. Sometimes it's just a mistake, but we'll see. Hey,
Yes.
Rosmal, how's it going?
Hello.
Hi.
Hello, Terri.
Hi,
Terri, you
Rosmal.
gave me a good rule of thumb answer or presentation. 12
Thank you.
watts per square foot on a vertical surface exposed to south orientation. Is that what you meant?
No. 12 watts per square foot is the potential. That's what the color itself will generate. But what the actual kilowatt hour production will be depends on the geographic location of the building and the orientation. So a brown panel will produce a certain amount of power on the south elevation. That same brown panel will not produce the same amount of power on the north elevation. And all of those particulars are figured out when we do an analysis on the building.
Okay, how do you start the analysis? You send the building elevations and the location coordinates, and you will do the analysis?
Yes. So Rosmal, if you were to send me architectural drawings on a project that you're working on,
Okay.
I would like to understand what the story is of that project. So I'd like to know what material you're looking at currently, what color or patterns you're currently looking at. Once I understand those particulars, then we can do an energy modeling analysis and give you a very accurate estimation of what the power the building will produce and what the cost would be for that specific application.
Okay, to make your life a little easier, this building is existing. It's coming up for recladding. The option we have is on the spandrel panel, and the color we have it already. It's the existing color, and the spandrel panels has to be replaced. And this is a good opportunity to integrate into a building. And I think we are on some kind of a track. I'm a sustainability person too, working with the MIT University on certain projects. So I am really interested in this, and I will get in touch with you.
Okay, thank you. I look forward to it.
Great.
Thank you.
Rosmal, great to hear from you.
Thanks. Thanks, both.
Okay. Cool. Okay, I'm going to go back to the questions in the chat, but if anyone else is feeling brave and wants to ask out loud, feel free to raise your hand. Okay, cool. So this one, I think maybe we covered, maybe we didn't, but what is the life expectancy of the solar collector, and can the unit be easily replaced?
Yes, and yes. So the life expectancy, as I said before, is minimum 30 years. Mm-hmm. How long after that, who knows? But I think 60 years, 70 years, who knows? Replacement is entirely dependent on location of the panel, system installation method, as well as the reason for replacement. I can tell you that if you've got 30,000 active square feet of cladding and one panel goes out, it makes no difference, because on the back of every panel is a bypass diode, ensuring that if something goes wrong, it goes around it, kind of like Christmas tree lights. When I was a kid, I was the youngest of 5, and I was the sucker who had to figure out which light bulb on the tree was burnt out. That won't happen anymore. So it won't affect the performance. So if only one panel goes out, it doesn't matter. But if an entire line goes down and it's 15 panels, then yes, that will affect performance. So we have to ask ourselves, why do we need to replace the panel? If it's physically damaged, that's obvious. But if it's because the panel is no longer producing and it's just one panel, and we also have a monitoring system that gives us live data 24/7 on how that building is performing. If a panel goes out, we will get a notification saying panel 14 on the west elevation on the 23rd floor is out, and we'll know. And at that point, you can make a determination whether it needs to be replaced or not.
Well, thank you. All right, for the solar railings, is temperature a concern, like someone leaning on it?
No.
Figure that wouldn't be good if they were heating up it.
That would be a problem.
Would be a problem.
It would be.
All right. let's see, is the product available for impact rated applications in high velocity wind zones? I think the answer to that was yes.
Yeah.
Cool.
Again, whoever is looking for specific testing information, we have a lot, and I'll email it to you. I strongly recommend, if you're having a hard time sleeping at night, put it by your bedside. A lot of technical information.
Yes, totally. You can also express in the poll that's still up. You can request certifications right through that. We'll go ahead and connect you with the Mitrex and Cloudify team on Acelab so that they can get you all those documents. Okay, let's see. Where are the panels manufactured?
In your backyard, technically. In Toronto, Etobicoke, Ontario. So for those of you familiar with Toronto, you know, Sky Dome and the CN Tower, we are a 10-minute drive north of that. Our fabrication facility is all under one roof. So we manufacture here. All raw materials come to us, and we fabricate all of our technology, active and non-active, in the same facility. Very proud of that. We're a 100,000 square feet facility. We are the largest manufacturer in the world, and we manufacture 25,000 square feet a day of our technology.
Wow. Very cool. All right. Is there an estimated lead time for ordering a custom surface design?
Yes. So depending on the size of the project will determine the length of lead time, but typically it could be anywhere from 6 to 9 months, or it could be 9 months to 12 months, depending on the size of the project. Manufacturing is not a problem when you're doing 25,000 square feet a day. That's not the issue. The issue is getting in the line, getting in queue in the facility. So typically, once we have approved shop drawings, anywhere between 6 to 9 months.
Cool. Are there ballistic resistant options?
Ballistic?
Yeah.
If that refers to impact, yes, we've had a ton of testing done on that. And again, that's in our testing information.
Okay, cool. I think I'm going to Google this real quick because I am not 100% sure.
Okay.
Oh, yeah, I think that's what I thought. I think that's referring to like guns, like testing with that. Do you know if that specifically was tested?
I don't know that we have shot a rifle in the general direction of our technology. I cannot say that. However, we have sent a 4x4 piece of wood hurtling at like 400 kilometers an hour to it.
Okay.
For impact resistant. I don't think we've shot at it. No. Okay. I'd be surprised if we did, but I don't think so.
It's unfortunately something we have to think about in America.
Unfortunately, yes.
Yeah. Are there typical size ranges for the BIPV cladding?
Yes. So yes and no. So we like to work with our standard size panel, which is roughly just under 4x6. And working with standard panels is great because we get the maximum performance. 72 cells on one panel, we can get a lot of power from that. We can expand it depending on the system that we are using to install. So if we're doing a rain screen system, standard panels would work. If we're doing a pre-assembled, we might be looking at larger panels. If we're doing a prefab wall solution, we are definitely looking at larger panels because that's a slab-to-slab connection, and it installs from the inside of the building. So it's still super lightweight, and we don't need a tower crane. But when you start getting into larger customized sizes, then we like to get involved in the project super early because it's a lot easier for the architect to work with what's available as opposed to being forced to work with one size.
Got it. Cool. And I see we've got someone else who's raised their hand. So Remy, I'm going to go ahead and unmute you to ask your question out loud. Let's see. Hey, Remy, how's it going?
Okay. Yeah. Just a quick question. That lead time is still pretty long, and I can see that's your factory is limited. I'm coming on board a project where the owner is basically going to manufacture all the components in their own factories overseas in South Asia. So I'm wondering, is there any possibility of collaboration with your company to get BIPV on this project? and working with the owner, maybe manufacture in South Asia for that region, as well as this project in Northern California.
I can't make any comments on, so you're concerned, you think our lead time is too long?
That feels a little bit long, 9 months, from shop drawing phase.
No. 6 to 9 months is the typical lead time. And once we have approved shop drawings, then that changes things. It could be less, it could be more, depending on the size of the building. That's just an estimation, but I can't make any predictions unless I see what the project is. But
Right.
I find it highly unlikely that you can order customized panels and have them manufactured and shipped off in less than 6 months from anywhere.
Yeah, it depends, on the panels and the cladding system and the curtain wall, all of that. Some are quicker than others. And I know overall we have a big lead time problem in building supplies,
Right.
which is why this owner is keen on ramping up their own manufacturing to kind of short, to make an end round around, as well as lower price overall by vertically integrated.
Well, if you've got a project, I would recommend reaching out to me. We can discuss this offline for sure.
Okay, yeah, super. Thank you.
You're welcome.
Cool. Thank you, Remy. All right. I get back to our Q&A chat. Let's see. I think this is an interesting project or an interesting question. So I saw a person asked earlier if there was any project that was too small for you. So yeah, a few folks in here are asking, like, can they be considered for a single residential home? Does it make sense for pricing purposes? If I'm just looking to maybe like replace my railing on, a personal single family townhome, would this product be a good fit for that?
Right. So, yes and no. We do have, for individual homeowners, we do have a separate line of products that you can order directly off our website. So if you want to replace your rooftop panel and you want it to look like your shingles and less obvious that it's solar, we have that. If you've got a home that has a brick exterior and you want solar panels that look like brick, we have that. But you would order that directly off of our website. That's for all single home purposes. You would not come to me for a project that is less than 10,000 square feet, because what's the point? I mean, it doesn't make sense. So no, you would not come to me personally for a small project. There are individual products that you can order directly off our website.
Awesome. That makes things even easier. Cool. Let's see. Some of these are complex. This person asks, it's kind of related to a question we went off of before, but a lot of solar products are uncomfortably hot to the touch. Is that an issue for any of these panels, specifically for the railing, but other close elements like cladding that building occupants might interact with?
No, not at all.
Cool. So, and then, oh, this is an interesting one. Is there a bright white panel option, and would that be the least efficient color? So yeah, this color of the cladding, like that.
So as I said before, at minimum, even a white panel will produce 12 watts per square foot. There are a lot of colors that, at first sight we would say are not great, but it doesn't matter because any color will produce electricity.
Cool.
Right? So we have, on one of the slides on the top right corner was a white railing. I don't know if you noticed it. That is our facility. And those are the panels that we installed out front. And we get asked all the time, why would you do white? Exactly. We did it on purpose so that when people come and see the monitoring system, they can see that even white panels are generating electricity to prove a point. Regardless of what color you choose, your building will generate electricity. The golden rule is the darker the facing, the better. And that's great when you can do it. But if you've got a client who says, no, I want a white building, then they can have their white building and have it produce electricity.
And you said that was like 12 watts for like a bright white building.
12 watts per square foot. Yeah.
Great. Awesome. see. Okay. So for single family homes, and maybe this is accessible on your website, how does the system's install cost compare to a more conventional panel? They realize this is not quite an apples to apples comparison because your system has more usage scenarios. But yeah, for like a single family situation, would there be kind of a higher installation charge, or maybe any sort of like installation learning curve? So like if I were to go and order a railing for my home, would I need to find a specific installer, or is that something that like most folks will be able to handle?
Yeah. So if you have experience installing solar panels on your own, then knock yourself out. If you don't, like most people, I would hire a professional. I don't know what the cost of hiring those professionals are. If you go on our website, we do have some recommendations for installers in various regions. We might be able to help you out that way, but essentially you would find an installer within your region. You would purchase the materials directly off our website, and then whoever your installer is, if they're worth their weight and the cost of them, they'll know what to do.
Cool. Great. All right, let's see what else is in here. This person asks about like different shape options for the solar railing. So how customizable is that? Could it be like rectangular, larger triangle, they ask? Or is that more of kind of a fixed design?
For balcony railings?
For the solar railing, yeah.
I'm
not sure what they mean by a triangle railing, but
yeah, for balcony railings, I've never seen triangular or anything other than just a standard rectangular. If that question is directed to cladding, then yes, there are different shapes that can be incorporated into a rain screen application. That is one of the reasons, or one of the benefits of having a rain screen system is we can pre-assemble our own facility. If you get online and you take a look at what our own facility looks like in one of the photos or one of the videos, we have multiple triangles that were pre-assembled and then installed on a interlocking channel system. So there's a lot you can do. What I would caution you on is the size of the panels. If the panels are too small, we can't fit active cells, right? Because you can't cut a solar cell. You cannot, once you cut a solar cell, it's no longer active. It would work for aesthetics. We can do a lot of cool things with, 6 by 6 inch blue cells or black cells, but you can't cut a cell. So if you've got a really large rectangular panel, then we could probably fit maybe 10 or 15 or 20 active cells on there, and you could do something with it. But it all depends on the size.
Okay, cool. All right, and let's see. What type of storage battery array do you recommend?
I don't, for a number of reasons.
Cool.
I will say this. A large building can generate a lot of electricity, but we are not yet at the point where the entire building is going to get you off the grid. That's not going to happen, not with the technology that's available to us all, not just us. So battery storage is not necessary. It is a high cost for battery storage, and I would never recommend it. And it's not part of our system. However, if a client wants it, that's fine. For the most part, you're looking at 40–50% of the building's electrical needs that can be provided by the facade, which is fantastic. And so what the building generates on a daily basis, the building consumes on a daily basis. In some scenarios, if you have an industrial building that is a big building and you're putting BIPV on the entire facade, plus you're putting rooftop solar, now we could be producing an excessive amount, more than what the building needs. In that particular case, if the client wants to buy battery storage and save it for a rainy day, knock yourself out. But in 99% of the cases, battery storage is not required.
Great. All right, I know we only have a few minutes left, so we'll try to get to a few more of these, but just as a reminder, if we don't get to your question today, we will have a record of it. And I just want to thank everyone again for all of these thoughtful questions. It's really great to see, so much interest and engagement from you guys. So really appreciate everyone who's asking questions and reaching out.
Yeah.
Okay, this is, oh, sorry. let's see. So someone asked if they can schedule a presentation for like a specific architecture firm.
Absolutely. Reach out to me directly and I will arrange a lunch and learn presentation. I do those presentations. So more than happy to do so.
Awesome. That's great. Cool. And then let's see. So do you have any recommendations regarding like ground floor downtown applications in terms of like city crime or city grime and vandalization, you know, some of those kind of like wear and tear situations?
For sure. So a BIPV is really, really good when you're looking at a building that has height, right? That is the biggest area of opportunity. A lot of times in the podium area of a building, a client likes the idea of someone going up to it and feeling that it's actually brick. It looks like brick and it feels like brick, right? So it really is dependent on the client. If the building design allows us to go BIPV right to grade, fantastic, we can do that. If there's nothing that's affecting shading, right? So if there's no trees right up against the building or another building right up against the building or other things, we can go to grade. It all depends on the design. But for the most part, my experience has been that clients like using other materials like porcelain or brick or real stone in the podium area where people can actually touch and feel.
Mm-hmm. Cool. Okay. See, we can do one or two more.
Of course. I'm in no rush. Keep going.
Great. And thank you, Terri, for breezing through all these questions. I know it's a lot of talking for you today, so appreciate
no
it. All right. Does the product need to be ordered in metric sizes?
That's a good question. Whatever the size is. So if you're asking in inches and we need to convert to centimeters, we'll do that. Or if you're asking in millimeters and we need to convert to inches, whatever, we'll figure out those specifics. That's not a problem.
They'll do some math for you. Don't worry about that. That's good to know. Okay. Oh, and this is a good one too. In general, how often does the surface of a panel need to be cleaned in a coastal environment?
Oh, that's a great question. I love that question. Guess what? It needs no cleaning because the panels have a layer of coating on them, on all of our technology. It's an anti-soiling and an anti-reflective coating. So what that means is every time it rains or snows or rains and winds, it's self-cleaning.
Wow.
So the maintenance on our technology is minimal.
Wow. That's very cool. And also, honestly, another way that you could end up saving some costs down the line if you're designing a large building that like traditionally needs a lot of maintenance in terms of cleaning, not having to do that at all would be great.
Yes.
Cool. All right. I've seen a few folks ask if it's possible to download a presentation or get the slides. We will host a recording of this webinar on Acelab's platform, so you can always access it there. And I will send over a link to that page in the chat right now, just so everyone has it. It's another great place to look and watch some of our older presentations as well. And you can bookmark that to check back for our updated webinar recordings. So that is in the chat right now. Cool. All right. And one last reminder about that poll, which we still have up. So that's a great way to get exact follow-up information that you need. Also, as folks are leaving, we have a very quick post-event survey where you can submit any comments or questions to us. So that's another great way that you can get in some other information. Let's see, we've got two hands raised. One is Remy. I'm not sure if that was from before, so I'm going to unmute Yusuf and see if we can squeeze in your question before the end of our time today here. All right. Hello, how's it going?
Hi, Terri.
Hi, Yusuf.
I just wanted to ask, how this product would be integrated with other cladding, let's say, in some location where you have shade and it's not efficient to put the product. How well can those be integrated, or what are the requirements to integrate those together?
It's very easy. Great question, Yusuf. Thank you for asking. It's very easy to integrate. So when we look at a building, we're looking at the entire building and hopefully applying as much active as possible where it makes sense. If it doesn't make sense, it's an inactive panel. From an aesthetic standpoint, it looks identical. You would never walk around a building and go, oh yeah, look at that panel on the 13th floor. I could tell that's not active. Never. That'll never happen. So from an aesthetic standpoint, it looks identical. If we're up against another building or a large tree or whatever, there's a projection or a cantilever design canopy that's coming over and it doesn't make sense, then we won't put active. And we can also incorporate other inactive materials. Our sister company, you know, we could do the same sandwich panel composition, but in stone or in porcelain or PVDF coating or whatever. So we have the capability as a company to address the entire building envelope, active, non-active, and other materials.
Thank you.
You're welcome.
All right, and I think that is all of the time that we are going to have today. But thank you again to everyone who joined today. Thank you, Terri and Tonya, for being on with us today. This was a really great educational presentation. And I really appreciate all of the questions that we got. It's awesome to have so much back and forth, to have folks raise their hands and speak out loud. So thank you so much, everyone, for your participation today.
Agreed. Thank you all very much as well.
Cool. All right, I'm going to go ahead and end today's webinar, but I hope everyone has a lovely rest of their Thursday.
Thank you.
Bye, everyone.